Isotopes versus ions. So a couple pages before, we talked about the different things you can do to an atom to change it. We said to create an isotope, we're changing neutrons. To create an ion, we're changing electrons. So ions are positively or negatively charged atoms, while isotopes are different variations of atoms in an element. Ions exist when there is a deficiency or excess of electrons, while isotopes exist when there is a deficiency or excess of neutrons. So we're going to decide if each of the following is an isotope, an ion, both, or neither. Let's look at these examples on the side. Isotope, an atom with a different number of neutrons than protons. So if you look at our picture, we take our mass and our atomic number. That's how we find our number of neutrons. That means we have 6 neutrons and 6 protons in carbon-12, 6 protons and 7 neutrons in carbon-13, 6 protons and 8 neutrons in carbon-14. An ion, however, is when we have a different number of electrons. So if we compare this sodium and this chlorine, this sodium is a +1 because before the change it had 11 protons and 11 electrons. After the change it has 11 protons, 10 electrons, which gives it a total +1 charge. Chlorine is also an ion because it started out with 17 protons and 17 electrons. It went and gained an extra electron, so now it has 17 protons and 18 electrons, giving it a -1 charge. So if we look here at carbon-12, if I look at the periodic table, the mass for carbon, or the mass of the most common isotope, is 12. So we can't be an isotope, and it doesn't say anything about having a charge, so it's neither. I'm just going to put in for neither. Neon. It just says the name of an element. It doesn't say that there's any difference in protons and neutrons and electrons. It just says it's neon. So neither. It's not a proton. It's not an isotope or an ion. Chlorine with a 38 on the top and the 17 on bottom. Well, the number on top is our mass, the number on bottom is our atomic number. 17 means chlorine. So if I want to discover if this is an isotope, I need to go look at the number of neutrons. The mass for chlorine on my periodic table is 35. Since the mass here is 38, we already know that this must be an isotope. And I don't see any indication of having a charge, so it's not an ion. For this one, it is only an isotope. Whereas the one below it, this chlorine, still chlorine, had 17 protons, and its mass is 33 instead of 35. This mass being off tells us it is an isotope, but before I decide it's for sure an isotope, this one also has a charge. So in this atom, both the number of neutrons and the number of electrons have changed. So this is both an isotope and an ion. These are not mutually exclusive concepts. We'll finish the last two here and use these pictures to answer these questions. Remember what a cation and an anion is? A cation is positive and an anion is a negative ion. That A in the end is a negative ion. So if we have our symbol, we always have the element symbol. So if I had carbon, this is our element symbol. The number on top is always our mass, on the top left. Number on bottom is our atomic number. And the number up here, this is our charge. So each of these locations are going to be important for us to be able to identify different characteristics about each element. So when you answer all of these questions, keep all this in mind. And for the table on the bottom, given the information that you are given, you should be able to fill out the rest. So this one was done all the way for you. You notice that we have potassium and it has a charge on the top. This means it's an ion. From this charge, you should be able to figure out your number of electrons. And the example problem is wrong here. Our number of electrons is normally equal to our number of protons, which is our atomic number here. So our number of electrons should have been 19, but now that it has a positive 1 charge, it means we lost an electron. So this answer here should not be 40. It should be 18. So we got our atomic number from the number on bottom, our mass number from the number on top, the charge from the number in the top right, the number of particles in the nucleus, well, our total mass comes from the total number of protons and neutrons, so that's 41. Our number of protons, once again, is our atomic number. Our number of neutrons is our subtraction problem, 41 minus 19 equals 22. So the only problem here was the number of electrons. If you look at the example above it, this is still potassium. It still has the same mass and atomic number, but the difference here is going to be our charge. This one does not have a charge. So the only difference in the numbers here should come from my number of electrons.